uh, 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 of Docker between the desktop and server, how virtualized deployment, traditional deployment differ from each other, and some basic commands to version check and the command executions. Going forward, we will also have understanding on the architecture of Docker, and then the how underlying technologies of Docker helping us to launch the containers and how it behaves in a real world, and the images when what's the difference between images and the container, how we can pull push container, create the creation and the sample, and then we'll go through the networking, uh, the host bridge overlay, all through the using the practical as well. The if we talk about the storage, the bind mount, volume mount, temp fs, all types of volume mounts we'll understand in the Docker, how we can make backup, create backup and restore images and the parameters through Docker file, each and everything. What is the use of Docker Hub and GitLab registry, which just came lately, and the local registry like DTR, Docker Compose, and Swarm. I understand these all things might be going through over your head, but just going through the course content quickly, high level. Then we'll go deeply for each thing. Docker Compose and Docker Swarm. Docker Swarm we'll just covering the high level because as of now and everyone understand it's the Kubernetes has taken over. So what's the difference between the Kubernetes and Docker? And the task deployments for this all the basic applications of WordPress, these all things, Docker file creation, and then finally we'll start with the orchestration of Kubernetes, deep dive with the architecture, API server, and the kube scheduler, core DNS, kube proxy, kubelet. These all are the part of the Kubernetes architecture, and how to deploy, what is pod, what is deployment set, all the stateful sets, and the static pods. These all replication controllers. These all things will cover one by one, even the demons volume, persistent volumes. So I believe you all have already have access to the course content. If not, let me know. I'll share the course content with you all. Or else we can start with the basics of with the containers and the Docker. Okay. Um, so before starting with it, I would like to explain um, how it can help you in the day-to-day activities if anyone wants to go with the certification. Mm, so this is the cloud native uh, cloud foundation uh, team. It's kind of a part of Linux Foundation subsidiary only. So they just handle the Kubernetes and Docker container things. So if anyone wants to go with for the certification, and in that, what would be the course content and in the certification, if you go training, then certifications inside that. So these all certifications for this Docker and Kubernetes we have, and if you see, these are the top three certifications which are widely everyone is opting for. And if you just learn, this is for, as you can see, this is for administrator, and this is for only for developers related, and this is for the information security or cyber security experts. So based on your need, you can opt for it. And if we go inside it and see the course content high level for this, yeah. So just so the CKA exam, which I just had, it would be around 2 hour hands-on command line based test, and it focuses on real-world tasks that a Kubernetes administrator would perform. Domain, the uh, first under domain, if you see the cluster architecture, installation, and configuration, so it has a weightage of 25%. So in that we will be covering setting up the cluster correctly from scratch or using tools like KubeADM. Then we have another domain, workloads and scheduling. which has a weightage of 15%. In that, we will be covering deploying apps using the deployments, pods, and ensuring they run on the right nodes. And then we have services and networking of total weightage 20%, where we exposing apps and making them reachable within the cluster or from outside. Further storage of 10% for attaching volume, so apps can store and retain data even if restarted. And then finally, troubleshooting of 30%, highest weightage, where we will be fixing broken board services, config issues, the most popular, important, and scored area. Okay,
For how many marks it will be?
so it's based on the percentage. If you have scored more than 66, you are cleared to the exam out of 100. Yeah,
Uh, for 200.
out of 100.
Okay. Is there any dumps available in the market or how it will be?
Yeah, we'll be providing the dumps, all the training course we'll go through, and the practical hands-on. So you will be having all the course content and the dumps from us only.
Okay.
Okay. Okay. So, and then, so this is for the more focused for the administrator. And if we look at another for the developer perspective, then in that it's also again 2 hours hands-on test focused entirely on the practical side of application development and deployment in Kubernetes. And here's how the topics are distributed for this developer course, where what each domain broadly covers, like um, application design and build for 20%, where we understand how to structure and create Kubernetes native applications using best practices. Then another 20% is application deployment to deploy apps using manifests, handle updates, rollbacks, and replicas. Going further, we have the application observability and maintenance, like monitor app health using probes, logs, and other runtime diagnosis under application environment configuration and security for 25% weightage. How to use config maps, secrets, and apply security policies and multi-container patterns. Uh, Further, lastly, the service and networking 20%, where expose and connect apps using services, ingress and egress, DNS in the cluster. So CKAD is developer focused, unlike CKA, which is more admin focused. So by the end of this training session, around 35 days, because it's 35 to 40 days it will take. So you will be ready to give both CKA and CKD based on your interest. You'll be able to give exam, and also it would help you in the resume for your day-to-day activities and in your resume for applying jobs. Any questions so far on the uh, certifications? And yeah, this is the CNCF. Yeah. So before we start, like we all, some want to have already know we have mix of knowledge here, and some wanted to understand from the basics. So we'll start with what are containers, the basics only. So containers are lightweight, standalone executable units that bundle an application and all its dependencies, so it runs consistently across any environment. So I'll explain it when I say lightweight, standalone. and what is dependency, and it runs consistently across any environment. When I say that, what does it mean? We will understand these all things. And then why Docker and containers they come together, because Docker is a platform and tool that made container technology simple, standardized, and accessible to everyone. So with Docker, you can easily build a container image, run it, share it, all with a few simple commands. Okay. So and the Kubernetes also we heard with the containers, that is an orchestrator. So once you start using containers at scale, let's say hundreds or thousands, you need help managing them, like launching, updating, restarting if they crash, scaling up or down. That's where container orchestration comes in. Tools like Kubernetes or Docker Swarm helps automate these tasks. Okay, so just so in this course, we'll focus first on Docker, then explore how orchestration adds another layer um, of power on top. Okay. So I hope everyone with me. My screen is visible, and we are at slide. What are containers and why Docker? Everyone is can see that slide, same slide, right?
Yes.
Okay, thanks. So what are containers? So like I said, we'll start from the basics. So let's break this down into three core ideas that help us understand the value of containers and the rise of Docker. So, left icon box. First, containers are a way to package your application, everything it needs. So, your application has the code, right? If someone has done coding, it has the code, it has the runtime, libraries, and it has the configurations. So, what containers does it packages these all things, whatever required for your application it needs, into one portable unit. So this ensures your app runs the same whether it's on a developer's laptop, a test server, or in the cloud or on a production server, wherever it is, because it's now a one portable unit. You just will deploy that container and just launch it. That is what container at a high level. Okay. Then on the middle icon gear, if you see under the hood, there are multiple tools that power containers, right? So LXC is one of the early containerized technologies, Linux containers, we call it LXC. So it's one of the early containerized technologies at the OS level. Then we have this uh, container D runtime. So is a runtime that executes container and is used by many platforms today, which is getting leveraged by the container D runtime is Kubernetes, and s- and Docker is a high level which is sitting on top of Docker, which wraps these technologies with an easy to use interface. And right icon igloo. Why did Docker become so popular? Because it simplified all the complexity with just a few commands. Anyone developer or admin uh, cloud build, run, and ship build containers reliably. So this led to Docker becoming the go to go standard for containerization. That's right. So if we move forward to the next slide, containerized architecture. Okay. So I think everyone can see the next slide, containerized architecture. I've started. So in that, so to start with, let's look at how containers fit into broader architecture of application deployment. So this slide illustrates the evolution from traditional deployment. If you see here, it's traditional deployment through virtualized deployment and over to containerized deployment. So on the left, this is the like traditional, like in the like in 90s, we were having the deployment. we have the traditional deployment model. So this is the most basic setup where applications are directly installed on the host operating system. So when I say directly installed on the application of operating system, you can imagine your laptop as well. Okay, so where you have a hardware on top of that, Windows is installed. Okay, and on that we have the application installed. We are installing like Microsoft Teams or the any VLC, all the applications on top of operating system. So this is the traditional deployment we were having. Still, it works, but only for our local work. But when we um, look for at scale at the organization level, it has many cons. So we'll discuss then why we move to the virtualized deployment. Now we are at the container deployment. Okay. So, first into the traditional deployment, for example, imagine you are running a web server, okay, and a database on the same operating system, web server and database on the same The database might require a specific version of a library that that a web server doesn't support. Okay, so which will cause a compatibility issues here. Additionally, if one application is compromised, an attacker, suppose one application means one application or web server is compromised, an attacker could get potential gain access to the entire system because both applications share the same operating system here. If we see, both applications share the same operating system and which share which without proper isolation, so which is means putting us on the vulnerable, making us more vulnerable. And also another reason I have given, the compatibility issues. Both are using the same operating system, both needs the same library but of different versions. So there we have the compatibility issues of the library. So to resolve this in the middle, we have we have this we have this virtualized deployment. Here we have a hypervisor that allows multiple virtual machines to run on a single hardware setup. Okay, but each VM has its own operating system. If you see, uh, we have one operating system, then the technology has developed a hypervisor, so that makes us install the multiple operating system on a single operating system now. That was the advantage we got after installing hypervisor. So the companies like VMware or the Oracle VirtualBox, you might have experienced. So we're installing we're creating multiple virtual machines on top of single operating system. So so here we have a hypervisor that allows multiple virtual machines to run on a single hardware setup. So each VM has its own operating system, which improves the isolation, which we were not having in the traditional deployment. So but comes at the cost of higher resource usage. VMs are heavier, so each VM is heavier, right? Because each one runs a full operating system, which takes more CPU, memory and storage. Because our operating system needs some CPU, memory and storage as well. So if we are solving here in the virtualized deployment, we are solving the issue of isolation and compatibility. But another issue have come up, like the we are now paying the higher cost of VM, CPU, memory and storage, because each operating system needs its own resources. For example, in data center, if you deploy 10 virtual machines, each one runs a full instance of an operating system, such as Windows or Linux. This means that even though the VMs are only running lightweight applications, the OS overhead, which is such as the background processes, because every OS has the background processes, services, drivers consume significant resources of our CPU RAM. There it is continuously consuming. So this can quickly become inefficient, especially if you scale up the number of VMs to like from 10 to 100 to thousands if we need. So to to resolve this issue, because we have resolved the isolation, but it is now costing us and more resources we are consuming. To resolve this issue, container has come in the picture on the right. So we see the evolution of container deployment. So container allow us to isolate the applications, right? Isolate the applications and their dependencies using the same host OS. The container runtime, such as Docker, manages the containers which are much lighter than VMs because they share the OS kernel. This makes container more efficient in terms of resource usage, faster to start and easier to scale. Any questions so far to understand how we have moved to the containers now from the traditional deployment, and what was our cons and why we have moved to containers now? If you understand this, you will understand the importance of containers. Okay, let me give you an example here for containers. Suppose you have an application that needs to be scaled up during high traffic, for example, on Christmas or Diwali, with on Amazon or Flipkart, you can say. So that needs to be scaled up during high traffic. So with containers, you can spin up 10 instances in seconds because they all share the same host OS. Each container only includes the application and its dependencies, making them lightweight, making them and efficient. In contrast, if you are using VMs, you would need to much uh, longer for full OS here uh, to boot up for each instance, consuming more resources like CPU and memory. So, in summary, containers are lighter, more efficient way to achieve isolation and portability compared to traditional and virtualized deployments. I hope everyone understands what how containers solve our issues and how it is benefiting us. Okay, I'll move to the next slide. So then we have container technologies. So in the previous slide, we have seen here container runtime and containers we have deployed, sharing the same operating system. Correct. So now we'll go more deeper to it. How internally this container runtime, these containers are inside. It is sharing the same host kernel. Still, they are isolated from each other. The applications. So we'll go more deep into detail. Okay. Uh, so so let's dive a bit deeper into the key components of container technology and how it works. So starting with the container images, these include all the necessary dependencies. Okay. Dependencies, libraries, and tools required to run an application. Think of it as a self-container contained package where everything the application needs is bundled together, which ensures consistency when running the application across different environments. When I say different environments, now you have run it on the Linux, Red Hat based, the same container image you can deploy it on the Ubuntu. Same container image you can deploy it on the Windows as well. So, so across different environments, either it's on the cloud or on the bare metal, your on premises. So same same container image can be uh, run across the different environments. So with this is the consistency we are achieving here. So unlike virtual machines, containers don't need a hypervisor. So when I say don't need a hypervisor, let me go back to previous slide. See here, we were having hypervisor, but here On top of operating system, we don't have any hypervisor. We directly install the Docker or Kubernetes on top of it, means the runtime we say, and just deploying the applications. So here, no hypervisor is required. There is only one kernel for all processes, right? So all the containers share the same host kernel, which makes them more lightweight compared to VMs. There's only one kernel running on the host kernel or VM, and the container runtime engine, like Docker or Containerd, is responsible for managing containers. So now speaking of Docker as the container engine, it performs several key functions. Okay, so when we say this container runtime, we have installed either Docker or we can either install Containerd. So Containerd gets installed when we install Kubernetes. It's inside it has that runtime, and with Docker the runtime is same name as the Docker. Okay, so what is its use case here, right? So it performs several key functions like loading the container. So on top of that, you see that one application of web server and another application of database, or any application which is running which you want to run. So it's loading up, spinning up that container, initialize the runtime environment. Like, so this the isolation between these two environments where the containers are running, but still they are isolated from each other. And handling over execution to the application, like uh, once everything is set up, Docker allows the application inside the container to execute. So whatever inside the container, the application we have, that application needs to now execute or run. So it needs some processes and files. So these all things which are providing from the host OS kernel to the application via the container runtime only. So that's the use case of container runtime, which is layer in between our application and the operating system. I hope this is clear. So we are I know I'm reiterating. So we are going with the basics so that everyone should be on the same page. So that's why we are understanding first what is containers and what is the need of it and how internally it is working. And going forward, we'll be having hands-on of each and everything, from deploying cluster to the executing commands and application. Okay. So now, and we have already understood the another key aspect of container is isolation. So so when we say it's isolated, so each process within a container, like each process within a container, ha assigned its own separate namespaces. So this ensures that processes running inside one container do not see or have access to the other processes on the host, okay, or in other containers. For example, one container might be running again the web server, while another is running database. They won't interfere with each other. So lastly, we have this namespace and C groups. Okay, so namespace and C groups, which is Linux kernel feature that containers rely on. So namespaces ensures process isolation by segregating things like process IDs, network, a file system for each container. C groups manages resources like allocation, making sure that each container only use CPU, memory, and other resources it's been allocated. So in summary, like again, containers are efficient, and it is providing us a level of consistency across environment while sharing the same host kernel, making them ideal for modern application deployment. Okay, before I move to the next slide, any questions? Anyone wants to understand it again? I can explain. Now, we have understood its benefits, like isolation, these all things, in technically, but from the fundamental perspective, the business perspective, how why business will opt this? The technical benefits we have seen there, because these are the adoption of application uh, containers in growing. So now moving on. So one of the reason is uh, for containers gaining widespread adoption is because of these several key other advantages that align well with our modern application deployment needs. For example, portability. So containers package everything the application needs, like code, libraries, and dependencies. So the application can run every anywhere, whether it's on premises, like we understand earlier, in the cloud, uh, or across different environments. This prevents conflicts that might occur due to variations in software prerequisites. When I say software prerequisites, it's the versioning system, compatibilities of versions, dependencies. Essentially, the containerized application can be deployed consistently across any platform, making it reusable and cross-platform situations. Uh, so, if you want to understand more, portability, imagine a development team that builds an application on their local machines. In a traditional setup, they might face issues when focusing that uh, uh, or moving that application to a staging or production environment because of different operating system libraries or software. So with containers, the application can be bundled along with all its dependencies. This means that whether it's running on a developer laptop or company provided data center, the application behaves the same way. Okay. Another is the speed, which we understood. So let's say you are developing a microservice that needs to be updated frequently with the new features. So without containers, deploying each update might take a lot of time, as you would have to ensure the development environment is ready, in, resolve dependency conflicts, and more. So with containers, you can quickly build, test, and deploy the microservice by packaging the up-to-date to new container image. The container can then be deployed instantly, ensuring rapid feature rollouts with minimal downtime and faster time to market. Uh, Lastly, the benefit of scalability, like great example, e-commerce site experience with high traffic during its sale. So in traditional VM setup, scaling would involve launching new VMs, um, which takes time and consume more resources since each VM runs its own OS. In a container, you can use Kubernetes to automatically scale your application by spinning up multiple container instances to handle the traffic. Containers use fewer resources because they share the host OS, meaning you can scale faster, more efficiently. That's it. Okay. Uh, no questions. I'll move forward to our architecture so that we can now finally go technically more deep dive on it. So yeah. So here, if we see, we have a client, we have Docker host and daemon, right? And we have images and containers. We have client, we have Docker host, and we have registry as well, right? Uh, so we'll go in depth for each in detail uh, for the Docker architecture, how it works behind the scenes. Okay. So on the left, we have Docker client. This is where we run commands like Docker build, Docker pull, Docker run. We will run this command once we will go do hands-on after this session in the next section. These commands are sent to the Docker. Uh, these are commands are sent to the Docker daemon, which actually does the heavy lifting. Okay. So, so at the center is the Docker host we have. So inside it, the Docker daemon is always running and listening for requests from the client. It handles container lifecycle like image operations and interacts with the registry when needed. Uh, we have the then we have the images and containers as well here. So inside the host, you see two key concepts like images. So in images like are like blueprints. They contain everything needed to create a container. And so when we will have more clarity what is image and containers difference. So uh, so right now it's kind of a blueprint. So whatever we need to create a container, we write inside a image. And then containers are actual running instances based on these images only. So the arrow is going from Docker client to the Docker daemon, and from which is always listening. Then from daemon to images. From that images, we have executed the container. Okay. And finally, on the right, we have Docker registry. This is where Docker images are stored and retrieved. When you use Docker pull, there is command Docker pull. You are asking the Docker daemon here. When you use, you are asking the Docker daemon mm, to fetch an image from the registry like Docker Hub or private registry. So it's kind of a where we have store all the registries. So uh, so popular base images like Ubuntu, CentOS, Nginx are stored here. We can see once pulled, they are actually cached local on the host. This is our host where we are working. So in summary, the client here gives instructions. The daemon processes them. Images come from the registries and containers are created from those images. So that's how we understood the Docker internals. So how Docker works behind the scenes, basically the conceptual or beginner friendly uh, Docker architecture, the flow from Docker daemon to registry to container. So next slide. In the next session, we will be you need to come with your AWS. Um, I hope everyone is familiar with Linux and AWS. So that's kind of basic prerequisites to understand and work on containers. So with their free AWS account, then we will be installing Docker. Uh, we'll doing on this in this session. We'll doing practical hands-on installing Docker, and then using Vagrant to deploy Docker, and we have understood the theoretically difference between desktop versus server. We'll be seeing via the practical hands-on how it is behaving differently and how this whole architecture which we just understood how it works. These all things we'll try to understand in the next practical session. Okay, I'll take a pause here. And any questions from anyone?